Okay, another technique for determining inverse Laplace transforms is through integrating. And, okay, now, but it has to be where f of s is going to be a particular type of Laplace transform. And here we have that if f of s is a Laplace transform that has a factor s raised to any degree, then we have for the inverse Laplace transform, we have f of t is equal to the inverse Laplace transform of f of s. And we have is equal to, okay, and having tau as the variable of integration, we have the integral as tau goes from 0 to t of the inverse Laplace transform of s times f of s dt, or d tau, and that is equal to the integral as tau goes from 0 to t of f of tau. Now, just to give you a little bit of a segue, and just looking at the inverse Laplace transform of 3 over s times the quantity of s minus 4. And if we look at the process through partial fraction decomposition, okay, so we have breaking up, we have linear denominator factors, and we have a over s plus b over s minus 4. Clearing out the fractions, we have 3 equal to a times the quantity of s minus 4 plus b times s. And we have two unknowns and two zeros that we can apply, so I can eliminate b and solve for a. In this case, we have 3 is equal to negative 4a, whereupon a is equal to negative 3/4. And if I eliminate a and solve for b, so I can set s to 4, 4 minus 4 is 0, a goes out, and then we have plus b times 4, which is 4b, and we have 4b set equal to 3, and from this we have b equal to 3/4. And so we have with the partial fractions, okay, we have a over s, we can write as negative 3/4 of the reciprocal of s. And as for b over s minus 4, we have 3/4 of the reciprocal of s minus 4. So going back to what we have here, so we have the inverse, I should say the Laplace transform. Okay, we have this sum of partial fractions. Now we're looking for the inverse Laplace transform. And so we have what is going to be negative 3/4. Again, just extracting the multiple, say negative 3/4 of the inverse Laplace transform of 1 over s. And again, the inverse Laplace transform of 1 over s is 1. And then we have plus 3/4 of the inverse Laplace transform of the reciprocal of s minus 4. In this case, we have e to the 4t. And we have, for the end result, we have f of t is equal to negative 3/4 plus 3/4 times e to the 4t. All right. Now, if we take the same Laplace transform and apply integration, okay, so this is our formula once again, and we have with f of s set to 3 over s times the quantity of s minus 4. Okay, and so just taking what we have here, so crossing over, so we have going from 0 to t, and we have of the inverse Laplace transform, again we have s times, and you have 3 all over s times the quantity of s minus 4. We have d tau, and okay, if you notice we have with s, s's will cancel. And so we're going to have equal to the integral as tau goes from 0 to t. And we're now looking for what's going to be the inverse Laplace transform of 3 over s minus 4 d tau and again 3 is going to be a multiple, and the reciprocal of s minus 4 is Laplace transform. Okay, we have e to the 4t, but I'm going to put this in terms of the integration variable. So you have, in this case, you have 3 times e to the 4 tau d tau, and integrating. Okay, so integrating with respect to e to the 4 times tau. Okay, so we're going to divide by 4, so the antiderivative. We have 3/4 of e to the 4 tau as tau goes from 0 to t, taking what we have with the upper limit, okay, so you have 3/4 of e to the 4t, and we have with the lower limit at 0, e to the 0 is 1, and we have minus 3/4 times 1, and we have for the end result in this case 3/4 times e to the 4t minus 3/4. Okay, and just comparing to what we had earlier, okay, so you have negative 3/4 and a positive 3/4 of e to the 4t. All right, and let's say that if you were to determine by integration, okay, say we have so if we were to determine our function f of t, and we have given that f of s is equal to 3 over s squared times the quantity of s minus 4. So you have a repeating linear factor with s. Okay, now for what we have in the case of f of t, now you're looking for the inverse Laplace transform of 3 all over s squared times the quantity of s minus 4. And if I put what I have in terms of integrating, okay, so I have s times, and you have 3 over s squared times the quantity of s minus 4 and multiplying the ratio by s. Okay, so we have remaining instead of s squared at the bottom, we now have at s. Okay, so, and I'm just going to work down. So I'm going from 0 to t. Okay, so I have the inverse Laplace transform on what is going to be 3 all over s times the quantity of s minus 4 Now, to an extent, we are reducing the amount of partial fraction decomposition, but it doesn't necessarily eliminate the requirement. It just lessens the number of terms involved. And now when we looked at the partial fraction decomposition of 3 over s times the quantity of s minus 4, so I had negative 3/4 of 1 over s plus 3/4 of 1 over s minus 4. So we have negative 3/4 times the inverse Laplace transform of 1 over s. And I have plus 3/4 times, okay, the inverse Laplace transform of 1 over s minus 4. All right, so I'm going from 0 to t, okay, right now. So I have inverse Laplace transform of 1 over s. Okay, again, that is going to be at 1. And multiplied by negative 3/4, I have negative 3/4. And I have plus, and again, for the inverse Laplace transform of 1 over s minus 4, again, this is going to be e, and we have raised to the 4 tau. And so we have 3/4 of e to the 4 tau quantity, okay, d tau, and taking the antiderivatives, okay, so integrating over the variable tau, we have negative 3/4 tau, and we're going to divide by 4 once again, so we have 1/4 of 3/4, so this is going to be at 3/16 of e to the 4 tau. This tau goes from 0 to t. So we have negative 3/4 of t. And we have plus 3/16 of e to the 4t. Now we have at 0, now minus negative 3/4 times 0, that goes out. And then we have minus 3/16 of e to the 0, so we have the subtraction of 3/16. So we have for the final result, okay, the inverse Laplace transform of 3 over s squared times the quantity of s minus 4 comes out to this particular trio, whereupon we have negative 3/4 t, 3/16 of e to the 4t, and negative 3/16.